only reason I don't look beat up is I got adrenaline from being in front of you all, so. Okay, so any other things from homework, anything from the quiz, anything?
The first problem, because you didn't specify that it was the population standard deviation.
Yeah, there you go.
Use the T-score.
T-score, yeah, totally. That first problem, you should use the T-score. Everybody. Because it said, we survey so many parents and we find their kids, still talking about the sample, ate a mean of this with a standard, okay, that standard deviation came from that sample. It wasn't the population one. So that's what I was trying to tell you. If you're like, I'm not sure, sample. If it was the population, you would know, no question, right? So if you ever caught yourself going, I'm not sure which standard deviation, that's the sample one. Does that make sense? Okay. All right. Okay. I was hoping me telling you we'd be leaving early would pick a few of you guys up a little bit. I'm sorry. I'll stop talking about how a lot of you guys look very upset. Okay. So, if there's no questions, we had one problem on one of the handouts that we skipped that I want to kind of come back to just for a nice little review. Which one was it, Jeff? Not that one. Was it on the back? Yeah. Remember we had the Chicago police one? I think it was the other side. You guys all have the Chicago police hypothesis test worksheet? Chicago. Okay. Let me make sure. Does everybody have, oh, sorry. Do you need that? Where did I just put them? Oh, is this my last one? Yes. Oh, here. No, here. Oh, here. Okay, good. Does everybody have the sheet that's about coyotes? That one's probably the most of it. As I say that, let me make sure I have any of them left. Oh, crap. If not, it should be up on Canvas. I think I don't have any left. Good job, Jeff. That is the most important one because it explains all the steps. Come here, you. Yeah, let's do this. So if you don't have that one, it's up on Canvas. It's the one that talks about the researcher looking into northern Minnesota coyotes, as you do. Oh yeah, we'll do that right after. That's a good idea. Okay. Boom, boom. All right, so I'm sorry. If you don't have that one, you want that one, get it from Canvas or shoot me an email or remind me to print one out for you if you don't have a way to do that. So the one I want to do right now, so much paper, oh my God. Wait a minute, why do I have that? Okay. Is this one. Which is funny because it's related to the 4-week stats course. So it's the other side of the one about Chicago police, right? Okay, so everybody has this sheet? Okay. So let's kind of do this one together. And then, as I promised yesterday, I've got a few studies that I just looked up just now, found some recent studies, and I'll show you how the work we're doing is actually, you can see it in these actual studies that have been published. Okay. So read through this real quick if you haven't already. Okay. So when you first read through it, when I teach word problems to students who are learning about word problems, I try to get them to understand that you read through the problem a couple of times, and each time you read through it, you care more and more about certain things. You read through something, the most important thing at first, the only thing you really care about is first is just what the hell's the claim. That's it, right? What's the claim that's being made?
That 282 out of 322 stat students agree that passing a 4-week stat course during the summer and actually keeping the information in their brain would be impressive.
Now, why would that not be a claim? Because wouldn't we just see it? That's sort of like me making the claim that you're here today, right? I can see you, so I know that's true. So that's the sample information, right? And I would take a sample after I've got some kind of a claim. So what is the claim somebody's making? And actually it just says,
Strongly agree that passing 4 weeks.
that's not a claim. That's kind of like the question, right? We would ask them, do you strongly agree this would be impressive? Yes.
It'd be that the proportion of students is
Yeah.
different from 84.5.
So I don't always use the word claim. I don't always use the word claim, but when I do. So the proportion of students is different from 84.5% of professors who say so, right? All right. So that 15.5% is like, oh, whatever. So what would that be in mathish? Proportion different from 84.5%.
P hat is not equal to.
No, sorry, I'm being so mean to it. P hat is the sample percentage. I can calculate that. I don't need to make a claim about it. Yeah, so P
P is not equal to.
not equal to
0.845.
0.845. Kick ass. It's very important to immediately change percentages into actual numbers. Oh, do you need this? Okay, give me a second. I just put them away. Here. Is it this one? No. I think I just gave my last one away. Yeah. It's the other side. I'm sorry. It's the back side of the Chicago police one. Yeah. Okay. And again, sorry, H1 is from an old version of the book I used to use. All right, guys. So far, so good? So the first thing, the only thing you care about, the very first thing you care about, you don't care about anything else except what the hell's the claim. So you look for something like claim. You look for something like we believe, we feel, it is thought that, right? You look for that kind of language. That's going to be what somebody thinks, feels, claims. And then you turn it into mathish. Where's it going to go? Which one of these old men? Yeah. The ha. Why is it going the ha?
It doesn't have equals.
It doesn't have an equal sign. It's the exact opposite of an equal sign, right? In fact, now that I put that there, so the claim goes into one of these two spots. It could be either one. And then the other one is just the opposite, because these are the two little men that think opposite of each other. So what's this guy think? Equal. Okay, let me stop. All right. Is this going to be a one or a two-tailed test? Two-tail. Why? Good. Not equal to. Evidence could show up above or below. Right? If I think it's not equal to that, I just want to find a sample that's far above or far below. That would mean not equal to. I love it. Two-tailed test. So when I don't have directional symbols here, right, less than, greater than, it's going to be a two-tailed test because either way works. Okay. What do I check to see if this is normal enough?
That'd be an IQ of greater than 5.
Kick ass. Greater than or equal to 5. Yes, I love it. And some books say greater than. Who knows?
And then you also need and
No.
greater than 30.
No. You don't need that. Nope. So all you need, so it's either n greater than 30 for means or NPNQ greater equal to 5 for percentages, right? So let's see. What is n? 322. And what's p? P equal for 5. I love it. So have you ever heard the phrase, assuming you're right, look at that shit, right? Like somebody, assuming you're right, look at that. That contradicts what you think. That's basically what a hypothesis test is. Assuming P really is 0.845, we're trying to find a contradiction to that. If it really is 0.845, a sample should be close to it. So what's the idea of a hypothesis test? Get a sample that is so far away from it that's evidence against that. So assuming it's right, look how far away we got. That looks like it's wrong. That's all a hypothesis test boils down to. But don't say what I just said on the test. It's bad. You've got to do all the steps. So 322 times 0.845, whatever the hell that is. I'm not even going to try. Let's see, 47. So that would be 275?
272.09.
272.09?
Yep.
That was pretty close. Hey. We're doing the, I don't know if you got this, the one with the Chicago police on one side? We're doing the other side, just to review, yeah. All right, what about NQ? What's Q gonna be? 155, kick ass. 49.91? Yeah. Every now and again. Okay, I like it. So, like, so often in a lot of math, we kind of forget the idea. So NP being bigger than 5 means the mean is far enough away from that wall. If the mean is here instead, it looks like it has room to go up, right? NQ actually sort of does the same thing on the other side. It makes sure the mean is far enough away from that wall, so then it has room to go up, room to come down. That's such a beautiful visual idea. It's almost too nice to believe. And again, from the earlier question, we just kind of noticed that from repeated simulations. So the fact that these are both at least 5 means what? Normal enough. I love it. Kick ass. Check. All right. Normal enough to do what? T and Z, I love it. Kick ass. I love it. So what do we got here? What's alpha? It just tells me, right?
Alpha would be anything beyond
0.10.
Oh,
And real quick, because this is normal enough, what can I use?
Z-scores?
Z-scores. If it wasn't normal enough, what would I do?
T-scores.
Nope. Sorry, I kind of set you up for that.
nothing.
Remember, percentages, I'll only use Z or nothing. And again, there's so much shit that works like this. Remember the 2 formulas for, I said this yesterday, I know I did, but it bears repeating. How many total formulas do we have for confidence intervals? 3, right? There's 2, means could be Z or T. What's the one option for percentages? Z. Bam. So formulas on your formula sheet could act as notes. It's kind of nice. So whenever percentage problem, it's either normal enough and I can use Z-scores, or it's not normal enough and I can't do anything. Okay, I like it. Felt like a Roman emperor there. Okay. So I know I can use Z-scores. Alpha's 0.10. It's a 2-tailed test. Don't say anything. Take a minute, just try to look up what would that Z-score be. I would look at the T-score chart. But, I'm crazy. Oh. What's up? Oh, you need this? Oh, shoot. I think I gave my last one away. Let's see if that's true. I think that is true. Yes. I had printed out more than there are people, but somehow I've given all of mine away. Okay. So I can print one out for you later. Yeah. Then I could just give you this so you have it. So what do you guys get for the z-score for this?
1.645.
Yeah, 1.645. So negative 1.645 and positive 1.645. Was everybody able to find that? Is anybody not sure where the hell that came from? Okay, so I'll show you both ways. So on the t-score chart, alpha's 0.10, two-tail test. And why am I using the t-score chart? Because I'll get a t-score if I stop, but I'll get a z-score if I go all the way down. And of course, the old-fashioned way would be, if I want to be 90% confident, there's 10% outside, so there's 5% down here. If I look up 0.05, I get there, and that is 1.645. Yeah. Okay, coolness. Because remember, your teacher is a jackass. I'm going to make you do, like, I'm going to have you test something with alpha equal to 0.07. Nah. And then you can't use the t-score chart then, because it doesn't have 0.07 on there, right? So you just do it the way we did it before we had the t-score chart. Okay. So here's my rejection regions. How would I put this into words? If I calculate z star, and it's what?
Z star is.
If it's less than negative 1.645 or
greater than 1.
greater than positive 1.645, what can we do?
Reject the null.
Yeah, that's why it's so beautiful. This is called the rejection region. If we get in there, we've been rejected. We can reject the null hypothesis. And just, all right, there's so many steps to this, and there's so many little details, and it gets really easy to just lose sight of the bigger picture. I know I teach math, but I'm much more of a big picture kind of person instead of a detail-oriented person, believe it or not. The null hypothesis. He's the guy who thinks it's in here. He thinks it's equal to 0.845. So any sample he takes, any sample that's taken, he's going to think that it should be close to 0.845. He thinks it's in there. This guy thinks it's not equal to that. So he thinks that any sample we take would be out here somewhere. So if we do get out here, that is evidence this dude is wrong, because he thought we should show up in there. That's the heart of a hypothesis test. That's why all this detail crap works. Yeah.
I get a little confused about the null and the alternate wording, just because as far as I know, I could be wrong, I'm not going to be an expert, is that in some fields, the null hypothesis is trying to disprove what is already in place. So like if you're trying to prove something, you want to try and disprove it and not be able to do that, right? So trying to disprove it, it's called a null, or they call that the null, but here the null is the original one. The alternate's the disproven.
Yeah, so just like, so real quick story. When I was taking physics, I had to take an engineering version of electromagnetism, right? All right, weird shit, yes, I know. So I was the one physics guy in a room of engineers, right? So they would be doing, let's do applications, and I'm back there, I need some theory. And everybody else, shut up, we need, I'm like, so, do you guys know complex numbers? Anybody? I, square root of -1. Engineers use J, right? So different fields will have different interpretations of certain things. Statistics, by itself, this is how it's set up. If you go out and you start to use statistics, you might kind of modify things just to be quicker or just because it's the way it's been done in that field. They all relate to the same concept. This structure is not what's important. It's just the structure that people picked, right? So other fields could kind of restructure it, but they all kind of is going to come out to the same answer at the end. They just kind of talk about it a different way. Okay, I like
I
it.
just didn't know if I had things mixed up in that, or if that is.
No, not necessarily. There are some fields that definitely do things a little different than this, but it's just the way it looks different. The analysis is actually the same. Okay. So again, what we're talking about, what we're allowed to use to talk about it, what's far enough away, right? How far does their sample have to get to show evidence? And then we're going to do, it makes sense. Right after I set up the benchmark, how far do we have to get? How far did we get? That's the next step, right? And z-scores, again, are distance. Don't say that on a test. It's the number standard deviation. But fundamentally, they are distance in statistics. So I want to see how far I got. That's why we calculate a z-score. What's n? 322. What's x? Number of successes? 282. So p hat's going to be x over n. You don't even have to know that formula. It's just the part divided by the whole. So what is 282 divided by 322?
0.875776.
876?
Yep.
Sounds about right. Sounds about right. Funk Soul Brother. Okay. All right. And now now I know everything I need. What's the one place I'm going to use this number? Right there. Everything else is referring to P and Q without hats, right? So this will be 0.876 minus 0.845 divided by square root 0.845 times 0.155 divided by 322. Oh my God. Okay. So take a minute, try to do that in your calculator. Don't say anything. Holy crap, Jeff. Okay. All right. Does anyone who hasn't said anything to me yet feel like they got that calculated correctly, want to tell it to me?
1.537.
Yeah, that's what I got. So right there, before we find this p-value, right, did we make it far enough away to show evidence that the null is wrong? No, we didn't, right? How? We had to make it this far away to show evidence. We only made it 1.54 away, right? So I want you to realize, right there we know the answer. Let me see if I can make this make sense. In real life, there's no alpha given. In real life, we don't get an alpha. In real life, we have our own alpha. So I'm going to show you, in fact, very soon, I'm going to show you this. They just report p-values. So if they say the p-value is 0.03, somebody can go, is that good enough or not? It's based on how they feel. What's the level of evidence? Don't we all have different levels of evidence? Right? You guys kind of with me? Some of you guys are like, oh yeah, ghosts exist. Oh yeah. And some of us are like, show me. I've seen the movies. I've seen all them shows with all the green, everything's green, and they're all running around crazy, and I don't see shit. I don't know. Who knows? Maybe they do. So right now, we know the answer. Did we make it far enough away? No. So did we succeed in rejecting the null? Did we succeed? 1.54 is right here. Is that far enough away to show that the guy who thought it's supposed to be in here, is it far enough away to show he's wrong? Nope. So then we fail. We fail to reject the hoe, fail to support the ha. What'd you do in class today, honey? Talked about hos and ha's. Oh, okay. Okay. Now, p-value. This is going to be interesting. So does anyone remember how to find the p-value? So if I kind of draw the situation again, because I got a lot of shit happening on this guy. Here's 1.645. The area in this tail is actually 0.05, correct? Is that cool? Because what was alpha? 10%. So there's 10% total here, right? So there's 5% on this side, correct? Okay, good. Our z-score that we found is 1.54. Can somebody tell me what area is in this tail? Is it going to be more or less than 0.05? More, obviously. Visually, you can see it's going to be more. Can you look it up? What area is above 1.54?
1 minus the area.
True. Do it. What is it?
0.9382.
So 1 minus that.
.0618.
0618. I know all too well. There's a lot of stuff coming at you. Alpha is the area in the tail or tails for the rejection region. P-value is the area in the tail or tails of our z-score, or z-star. It's a beautiful analogy there. Here's the problem. Let me see if you guys are cool with this. Is this alpha? Is that alpha?
No.
Nope. That is exactly
Alpha 2.
half of alpha, correct? So this is not the p-value. If I have a two-tailed test, I have to double that. So what is the actual p-value if you double that?
0.12.
Yes, cool. All right, so here's something I don't think I've said directly. If the p-value is less than alpha, we reject the null. And again, the p-value is a measure of the likelihood that your sample ended up where it did out of chance, that the middle really is what this thinks it is. So this had a 12% chance. That's not small enough. That's not small enough. That's not a reasonable doubt. That's not small enough to say, so we didn't make it far enough. So either way you look at it, if you compare z-scores, we didn't make it far enough. If you compare p-value to alpha, we didn't make it. It's not less than 10%. So again, I've said this in a few different ways, but the alpha is related to what we're defining unusual to be now. So in this problem, we're defining 10% chance of something happening to be unusual. What we just did only had a 12.36% chance. It's not unusual enough to change things. It's not enough evidence to say, no, it's not the same. It's not 0.045. Yeah.
I just don't know if you're being careful about your wording or if it's a shorthand thing. If the p-value is less than alpha, reject the null. Do you also support the
Yes, reject the null is the same as saying support the ha, yeah.
Okay.
If there's two people and they have different opposite opinions, if I say this guy's wrong, I'm automatically saying the other guy's right.
That's
Yeah.
That makes sense. I just didn't know if there's something I didn't know.
But no, it's a good point, yeah. Okay. All right. So now we can write our conclusion. We're not done, yeah.
That we found sufficient.
Oh, okay. Our z-score is 1.54, right? So if we look up, so the p-value is the area our z-star makes. So if I look up 1.54, 9382, right? That's the area below. I want the area above. So I just do 1 minus that. Yeah. Kick ass. Yes.
And Z star, That's the Z-score for a sample, correct?
Yes.
Okay. I'm a little confused though, because didn't we find the Z-score for our sample to be 1.645 earlier?
No, definitely not. Did this have anything to do with the sample? Where did these numbers come from?
Those from our alpha and,
Yeah, that came from the theoretical. Where does it start to have 10% outside of it is 1.645 standard deviations away. Had nothing to, the sample could have been anything at that point. I could just not even know what the sample is and I could look that number up. All I needed for that was the alpha and the number of tails. Does that make sense?
Yeah.
So that's why I call this Z star, because we already have a Z on the playing table. So I just want to differentiate it. Yeah. You're not going to see Z star. I don't think any other teacher is going to use Z star. It's just my own creation. Which is the thing about math. Make math your own. Math is just a bunch of shit a lot of people in the past decided on. Right? Real quick, let me go off on a little semi-rant. Very quickly. This is confidential. What does that symbol mean? Why does it mean that? Did some aliens come down and say, you will use this symbol
Opposite.
or we will come back and destroy you? And you're like, oh, okay, we'll use it. Huh?
It's the opposite of D.
It's just a square root of 9.
This is square root of 9. Why does it mean that? Because we said so, right? Could this have meant the square root of 9? Sure, of course it could have, right? And you're all like, okay, Jeff, whatever. But I like to point out to people, in fact, the history of the square roots, the history of a lot of symbols. Sounds like a book you would read to help you get to sleep, but it is kind of an interesting history. All that aside, I'm really sorry. I have no idea why I went off on that. Who got me into that? I forgot now. Shit. Any opportunity, I'll talk about it. Okay. So a lot of the stuff that was come up with, we just have to kind of like catch up with. How do I write this conclusion now? So here's our short conclusion. We didn't make it far enough, so we failed to reject the null and we failed to support the alternate. Which one was the claim?
it's not equal to.
Yeah, so the ha was the claim, right? So what language am I going to use? That language, the one that talks about the ha. Does everybody see that? Does some people get all the work right and they're like, I don't know how to write the conclusion. I just take a guess and I hope. No, you pick the one that's actually talking about the claim. So then you do exactly. Fail becomes, we have not found sufficient evidence. That's what fail becomes. We have not found sufficient to support. Ha was the percentage of students is different from the 84.5%. Okay, so we have not found sufficient evidence to support the claim that the percentage of students agreeing with the statement is different from 84.5%. Whew. So again, that's the part where you just copy, because you need to have the claim in there. So just go ahead and copy it down. By the way, this is, oh my gosh, percentage of students. Okay. I always feel like you need a Rosetta Stone to figure out what the hell I'm writing. Okay. So we've done a lot of hypothesis test examples. Let me ask you this. I am trying to get us out like the earliest ever today, because I just feel like we all need that. Does anybody disagree? Anybody upset? I'm not going to let us out now. Don't get too excited. I'm just saying we're not going to take a break. I want to make sure everybody understands. We're going to put the break at the end. And I'm going to give you like a 40-minute break so at the end. All right, so basically just leave. Okay. I will say this. Let's do this. Okay. chapter 9, there's one thing left to talk about, and then there's one section in chapter 10 that's actually exactly related to this stuff. The one thing I haven't talked about yet, yeah, sorry.
I was saying, that was my question earlier, that was just about tricky on my hand. I was like, when you said we're going to chapter 12, I was like, what did 10 and 11?
11 we're going to come back to.
Got it.
So just to make sure, if you look at the homework sheet, it looks like I can count until I get to the end, and I do 12 before 11. That's because chapter 12 is much simpler, and it's a nice little breather. And then chapter 11 is where we get our last chart. We have the z-score chart, the t-score chart, and then we get one more. All right, this one will be the funkiest one yet. So I kind of like to give us chapter 12 as kind of like a little breather. We'll see if you agree with me or not. Okay, so that's why I do it out of order. The one thing I haven't talked about from chapter 9, let me ask you this. So if we do a hypothesis test, what are the two conclusions I could come to? There's really only two things.
Support or reject.
Those are the same thing. So that's one conclusion. So one conclusion I could come to is reject the null. So I just wrote up there support the hop, right? Okay. So you're right, Sean, the way you said it earlier, it's a shortcut way to say it because that captures both those statements. Okay. So one conclusion I can come to is I reject. I find enough evidence. So of course there's only two things. I either get in the rejection region or I don't. So of course there's only two things that could happen. So either I reject the null or
Support the null.
no. Never support the null. No, stop. If there's one thing I want you to learn, stop. I'm sorry. You can't support the null hypothesis. You can't. There's no evidence that you can find to show something equals something. You can only show evidence against that. Right? If I take a sample and I get a mean of 10, does that mean is that evidence that the actual mean is 10? No. It isn't. Because every sample can have any kind of variability it wants to. So I can either succeed and reject the null, or I can fail to reject the null.
So Professor,
Yes.
so those questions where they say, oh, we think the mean is like here, they just kind of come up with that then? If you can't find evidence to create a null, can you only say we only have no evidence against it, or?
You could have a reasoning as to making a claim, but the test itself can't verify equality. You can only test for inequality. You can only test if it's less or greater. And it kind of makes sense. You can't ever prove that something equals something exactly, but I can certainly show evidence that it's not equal to that. Equal to something exactly is very specific. Not equal to is more general. That's why it makes sense. I can show evidence that it's not equal to something. Okay, maybe. Let's not get stuck on that. Does everybody agree? I can either succeed or fail, right? Oh man, I should have done that. Shoot, I always forget to do that. Let me just describe this to you because it's too bad for me. Somewhere on campus, I have some little green and white blocks, right? And what I would do sometimes is I'd put them in a bag and I'd start to go around and people would pick some out. If I went around the first 10 people that picked some out, it was all green. What would that be evidence for?
That there's.
Like so there's some green. I tell you that I put some green and some white in this bag. And I walk around and people start taking, and the first 10 people everybody took out a green one.
The evidence that there's a lot more green than white in there.
Okay, good. One thing you can, so that would lead you to make a claim that the percentage of green is more than the percentage of white in the bag. Yes? What's another possible claim you can make? That there's no white in the bag, right? Maybe I'll just put all green to guarantee. In fact, that would be one way to guarantee it came out all green. You with me? Or I'll have a deck of cards and I've replaced all the black cards with red cards. And I have so many people take some out and the first 3 I say, can you come up with a claim? And there's nothing yet. There's not enough yet. But after the first 10, it's like, wait a minute, you didn't put any freaking spades or clubs in there, did you? Right? You guys kind of with me? So that kind of goes to what you're saying. I have to have some level of an idea to formulate a claim in the first place. If we kept going and we kept picking and everybody picked out a green, that would be evidence that there's only green in the bag, correct? Is that necessarily true?
No.
Could there be like one white in the bag? Are you with me? Okay. You could conduct a hypothesis test perfectly and still be wrong. Some people see that as, God damn it, statistics, I do all this work and I see it as it's frickin' being honest. When we come to somewhere we're like, I don't know the level of pollution in this lake, and we take samples. I could just happen to, I don't care how carefully I try, I could just happen to take samples that have pollution. If I would have taken them any other place, so I'm like, holy crap, the level of pollution is insane. When in reality, not really. It's just little pockets or something. Are you kind of, I don't know, that's not a great example, but you guys kind of with me? So if I reject the null, what is the mistake I could have made? When is it bad to reject the null? When is it bad? So if the claim is there's nothing but green in the bag, right? When would it be bad to reject that? If in reality, so the statement, there's only green pieces in the bag. When would it be wrong to reject that? If in reality there really is what? Only green in the bag, right?
Wrong to reject that if you got picked all greens and said it anyway.
No. Okay. Let me see. Okay. Let me go back to a very boring example, just because. There is an actual average age of everybody on this campus right now, correct? It exists. It exists. Do you know what it is?
No.
None of us know. If we conduct a hypothesis test, like somebody says, I think the average age of everybody on campus is over 25. We do the whole hypothesis test correctly, and we reject that. Let me say this better. We think the average age is 25, and we reject it. Are we correct? When would we be wrong? If the actual age really is 25. If null says the mean age is 25. So here's an example. The null says the mean is 25, and the alternate says the mean is not 25. And we reject this guy, which means we show evidence for this guy. When would we be wrong if in reality the mean actually is 25? You guys with me? I really want this to make nothing but sense. It has nothing to do with the work we did. We will never be able to get reality in almost any statistical analysis, because in most statistical analyses, are we looking at the entire population? That's the only way to get reality. We're only getting a feel for what reality is, correct? There's always, when I do confidence intervals, is there a chance we're wrong? Yeah, give or take 4% or whatever. When I do a 95% confidence interval, there's a 5% chance I'm wrong, right? When I do these, alpha is sort of related to one of these mistakes that I can make. Yes?
So stats has the most allowance for human error.
Say again?
Stats has the most allowance for human error.
Stats is one of the math disciplines that allows for the possibility of error. Yeah. Like algebra, most of what you see, it's like concrete. X is 7, right? Or even, there's no answer, right? It's very concrete. Statistics is like, well, that ain't life. Life is like, I don't know. Okay, maybe. Okay, I really want this to make sense. So there is a truth. So let me try it this way. Let's say in reality, I don't know. What do you got, Jeff? The average, yeah, sure, length of a dog's tail is, what makes sense here, Jeff? I don't know, 8 inches. No, it's terrible. It's out of 11. Okay. So in reality, that's the average, correct? We don't know. Some freaking, MCU God knows this. No, it's 11. We're just humans. So what do we? So this is reality. This is little humans. You're really weird today, John. Too bad. Little humans. We're like, we're never gonna get this. We're not gonna be able to look at every damn dog. Yes? No, nobody can look at every damn dog. Are you with me? Okay. We take a sample and we do an hypothesis test and we reject mu is 11. We reject it. And we did everything perfectly right. Everything perfectly right. Yes? So did we make a mistake? Not in our work. Did our work result in an error though? Right? If the mean really is 11 and we reject this statement, we made an error. Yes? Or there was an error made. Let me say it like that. Okay. So if we reject the null, that would be an error if we reject a true null. So every claim that's made, there is a reality to it. Right? When somebody's caught and they're thought to have committed a murder, and it's not on, even if it was on video nowadays, who knows? Could have been a deep fake or something, right? So nobody knows 100% certain, correct? So if we reject that they're innocent, could we have made a mistake? Which is why, of course, we're not going to get into the politics of freaking death row and all that kind of shit, but we have certainly killed innocent people. Kill us. Sorry. Huge thing about that. Okay. That's a grand example of a horrible place to make a mistake. Okay. So rejecting a true null is an error. It doesn't mean we made a mistake mathematically. It's just because we'll never know what the actual answer is. When is it wrong to fail to reject the null? When is it wrong to fail to say that the null is incorrect? When the null actually is?
Correct.
When is it wrong? This is funny. There's so many negatives in this sentence.
Incorrect.
When is it wrong to fail to say the null is incorrect when the null actually is incorrect?
Correct.
So, the second type of error is to fail to reject a false null.
Oh, so you're accepting false.
Never accept. We just fail to reject. Sort of like saying guilty or not guilty. We don't actually say innocent. We don't accept that they're innocent. We just fail to reject that they're innocent. Okay. I like it. Interesting, yes? Because any analysis we do, it can never show us the truth. There's a truth, right? And this is not suddenly going to become some weird join my cult. No, there's a truth, correct? Any analysis you do, all it could do is give us confidence that it's this or that. That's all it can do. And of course, that's all we can do as humans in this world. Holy shit. Okay. So let me give us a concrete example. Let me give us a non-mathematical example. And then I'll give us a mathematical example. And then we'll talk a little bit about chapter 12, and then we'll head out nice and early. So these are the two. This is actually the type 1 and type 2 error. That's their actual name. Type 1 error, type 2 error. Okay, so you'll see that in the homework. So here's the non-mathematical example.
Human.
Let's say you're a battlefield medic. Right, or some big. In my brain right now, I see a Lord of the Rings kind of thing going on. Right, you're the cleric, and you're going out there delivering potions and so forth. Anyway, okay, sorry. Or you just World War II medic, right? If you want to keep it real. And when you approach somebody on the ground, so you're out there in the field and you see people laying down, what are you going to do when you approach somebody? If they're just laying there, eyes closed, what are you going to look for? You're going to see if they're alive, right? So let's see what you guys think. What will your null hypothesis? What are you trying to find evidence for? That they're alive. So what are you trying to work against?
They're dead.
They're dead. Okay, so the null would be the person has expired. Right? And the alternate would be the person is still alive. Okay. You guys with me? Because when I approach, I'm trying to find evidence that they're alive. Correct? So, what would a type 1 error be? What is it just? The way I remember type 1 and type 2, type 1 is a short phrase. Reject a true no. Type 2 is fail to reject a false no. Right? Small things, big
Type
things.
1 error in this scenario would be.
So just in general terms, it's reject a true no. So when you see this, you say, okay, in reality, what? So if I reject a true no, what's true? What's the reality? In reality, the person is
That
dead. But we think they are alive. Everybody with me? So in reality, whatever the HO says is true, but we think the HA is true. We think the HO is false. Are you guys with me? That would be a mistake. Because then I would start trying to revive them, and they're already out of my. I don't have enough equipment. I'm not going to be able to like bring them back. I don't know how long they've been laying there. So in essence, I'm wasting time on somebody when other people around could need help. Okay. Sorry, this is so morbid, but a lot of stats is. So what would a type 2 error be? Type 2 again. The general phrase is fail to reject a false null. So in reality. The null is false. So what in reality what?
They're alive.
Yeah. They're alive. But we think they are dead. And what will we do then? No, we don't have time for that. We'll just move on, correct? And they're like, "Woo," correct? Sorry. Humor in such a thing, but oh well. That's bad, yes? Anybody have any feel for which one of these is worse? They're both pretty bad. I would say type 2 is more immediately bad, right? Because then somebody's like, oh good, oh, where are you going? Right? Okay, and I'm sorry, okay, you're fine. I do have a dark sense of humor, but I don't want to. Okay. Alpha is the probability of making a type 1 error. That's what alpha is. Because alpha, let's say it's a two-tailed test, right? Alpha is this, correct? And if this is true, if the null is true, the picture does look like this, what's the probability we end up there? Alpha, correct? The probability we get out here is alpha. Is that cool? It's okay. Things are happening, but we're fine. You guys all with me? I really want you to get this because isn't alpha different sometimes? What's the most immediate reason alpha might be different? If the type 1 error is the worst. Or is not as bad. If the type 1 error sucks, wouldn't you make alpha lower? If alpha is the probability we make a type 1 error, wouldn't you want that error to be lower if the type 1 error is the worst? It sucks. I would then lower alpha. In this case, the type 2 error you're saying is worse, and I kind of agree with you. Then we would make alpha bigger. You guys semi with me? If alpha is smaller, the probability of this is bigger, and vice versa. That is why I can finally explain to you why we don't keep unusual to be 2 steps. Because alpha is the probability of making a certain kind of error, and in some situations that error could be really, really bad. So it could be as big as this, as big as life and death, or it could just be an insurance company going, I want to make a lot of money. So, you're going to set their alpha to be 0.005 or something, or 0.001 to show evidence that my insurance should go down. Because to them, the worst thing would be not making a lot of money, right? Okay. Like it? Okay. Sorry if you work for an insurance company. Okay, so hopefully that makes some sense. Everything you do, especially in statistics, immediately, very obviously, you could be wrong. I mean, and again, people take that as, well, statistics is dumb because it can't give you an answer. And I'm like, that's frickin' life. That's why I love statistics, because it's life. It's the most honest math. Okay, I'll stop. So you'll see a couple questions in the homework. But let me do one more example. Yeah, just a more mathematical example. The mathematical one is going to be, not surprisingly, a little more boring. But if I have a statement like, let's do P. P less than or equal to 0.11, P greater than 0.11, type 1 error. What's a type 1 error? When I reject a true null. So in reality, what is true? In reality, the percentage is no. What does HO say?
It's less than or equal to.
Yeah, is it most 11%? Well, we think it is true, but be a little more. In reality, it's at most 11%, but we think it is more than 11%. That's all I'm saying. Right? So in reality, the percentage of whatever it is at most 11%, but we think it's more than 11%. That would be wrong. We didn't make a mistake. It's just an error because that's how life is. We think it is more than 11%. A little less interesting. What would a type 2 error be? In reality, what?
I failed to reject the false node, so we would be reality.
So this guy's wrong, correct?
Right.
This guy's false, so this guy's true. So in reality, the percentage is
Greater than or equal to
more than 11%,
11. But we failed to reject that, so
but we think it is
less at most 11%.
at most 11%. Exactly. Okay, cool. That's going to be more like what your homework is going to be. There's a few problems. That's all you do. Type 1, whatever this guy says is true, and we think it isn't. Type 2, whatever this guy says is true, and we think it isn't. That's really all it boils down to. 11. Okay. All right. Yeah, let me do, okay, I like this. So I'm going to talk a little bit about this next thing, and then we'll finish it up tomorrow. I gave you the practice test already, right? Okay, so I have that answer key tomorrow. So let's talk about chapter, oh yeah, let me say one thing about chapter 10, that's right. Probably the most important thing I'll say about section 10.2 is I'm going to make it extra credit. So I'll just say that right now. Everybody hear me? Section 10.2, extra credit. Also, before I forget, let me put this up here. Let me write that up here. Make it really, really efficient. Oh.
So like the homework?
Yeah, 10.2 extra credit. So you can just not do it, and you're good. You could try it, and you could possibly get some extra credit. So all I'll do is if you do it and you get extra credit, I'll add that to your homework grade. Does that make sense? Doesn't have to be perfect to get something exactly the way I grade anything. But if you get it perfect, I normally give you like one full homework assignment. So if you missed one homework assignment, this would take the place of it. If you do all your homework plus this, then you'll have like 100 and something % homework average, which will get factored into your grade. Okay, I like it. I will say this one thing. Here is the Z star for when I have one sample. Yes? In fact, let me be more explicit here. Right? Isn't that what sigma x bar is? Is that's all I did, right? You guys semi with me? This is if I have an established average and I'm comparing one sample's average to that. Is that cool? That's what we've done so far. What do we do with drug studies again? Wouldn't we give the drug to one group and the other group gets a placebo or something? Wouldn't I then be comparing their average time until they get relief or whatever? It wouldn't be an established. It would be two samples that I'm taking. One sample gets the drug and the other sample gets a placebo, correct? So just to kind of truncate this whole thing, one little thing I want you to realize, let me see if you guys get this. I'm going to write this. You guys all see how those are the same thing? What's the square root of sigma squared? Sigma. What's the square root of n? Square root of n. Same things, right? So in case you want to try section 10.2, it's going to be hypothesis tests. It's going to have the same 5 steps. There's going to be a few little minor changes, and you can read about them, but the biggest change will be step 4, where we calculate z star. So for section 10.2, we're going to have 2 samples. So instead of one thing, I'm going to have 2 things. And I want to know how far apart those samples are from each other. Does that make sense? Right? If I give a drug to 2 different groups of people, like, I give a drug to one person in one group and I give a placebo to the other, do I want to see how different their reactions are? So here's one sample, mean, minus the other one, to see how far apart they are. Now watch this. Instead of 1 standard deviation, I'm going to have 2. Because they're going to have 2 populations here, yes? So I'm going to have 2 sample sizes possible. So just everything doubles. So it's exactly the same as this, it's just that everything doubles. Okay, and again, that's if you want to try a section 10.2. It has the same exact 5 steps. There's a few little differences. This is the biggest difference. Okay. So that's why it's extra credit, because that's the lecture on section 10.2. Okay. Oh yeah, let me show you before I forget. There's so many things. And again, just in the vein of statistics is almost always morbid. This is a study about if you're socially isolated, lonely, how does it affect your mortality rate? I don't care. We're not going to look all through this, and you can read it if you want to. But notice something. Here's the 95% confidence interval, right? In fact, they just spell it out. What's right after that?
P-value.
P-value. 0.001. Anybody have a feel for what that might mean? Is that a good p-value if you try to reject the null? Like, I don't know, dude. You said a lot of shit today. So the smaller the p-value, the less likely it is that the middle is where the null thinks it is. So the smaller the p-value, the more evidence against the null. You will never see alpha anywhere in this shit. They just give p-values. So look at this p-value, 0.03. There are tests we've done that this would not have passed. But less than 0.001, basically everybody would say that's significant. 0.03, some people would say it's good, some people would say it's not good enough. In fact, let me see, I got another, I can't remember, is this less morbid? How hot is too hot? Yeah, this is a little less morbid. Was this the one? Oh, here we go. All right, here's the actual study. This one I like because, let me show you. Can you find it really quickly, Jeff? Where was it? Where was it? Oh, Jeff, you suck. Let's see. Oh, here we go. Beautiful. I mean, look at how they say this right here. Let me kind of zoom in a bit on this. Bum, 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 bum. All right, this is kind of nice the way they say this. Data are presented as mean plus or minus standard deviation and with a significance of p less than 0.05, some evidence, or p less than 0.01, strong evidence. Okay, that kicks so much ass. I'm sorry. And you guys are all like, okay, man. Stop fawning over your statistics. So like 0.006.
So it's better if the p-value is low.
A lower p-value means it's less likely your sample was just randomly weird. It's more likely the actual middle is in a different place. So again, if the middle really is here, where are you pointed, by the way? Oh, you're here, so you haven't seen Chuck. If the middle really is here, it should be really unlikely to get a sample there, right? How unlikely? Whatever this area is, so let's say 0.01, right? So if I get a sample here, there's even less percentage below. This might be a 0.003 chance of happening. So the lower the p-value is, the less likely the sample just happened and the middle really is here. What's more likely is the picture maybe looks like that. The middle is actually higher. What happens if I push the whole thing up? Doesn't this become more likely now? Okay. It's never 100% certain, but the smaller the p-value is, the more likely it is that the middle really is in a different place. So when I see 0.006, I'm like, holy shit. So strong evidence that, oh shit, I don't want to look through this whole thing, whatever the hell MR is. MR. Metabolic rate during rest, oh, that makes sense. Metabolic rate during rest increases in the highest heat stress conditions. So it's a really strong evidence for that. Okay. All right, and you guys didn't see any of that, but you know, sheet at 0.06. Okay. All right. Okay. Lost 8. Oh man, 8's gone. Okay. So last thing for today. Oops. Hopefully you got some 10-2. Let me give you this. I think I told you about this already. So after the absolute insanity of hypothesis testing and all that kind of stuff, this will hopefully be a little better. One thing about this chapter, it's the one chapter that I allow us to just use calculators for the most part, because the calculator part is just one piece of it. And I'll show you, I'll show you the formula or involved for part of what we're going to do, just to show you why I want to use a calculator. There it is. Okay, look at that. Gaze upon this. Oh, sure, thank you. All right. Now, if anybody out there is like, man, I want to do that formula, I'm sorry. Okay. So just to show you, I mean, this is kind of busy work, really. That's why I'm okay with just using the calculator to get this. It doesn't really help us understand concepts to do all this. One thing I want to point out is that these two bits here, that's related to the standard deviation in the x's, and that's related to the standard deviation in the y's. Okay, that's one little thing that would come out of this. Okay. Now, we don't even know what that formula is for yet. So, here's the idea. Let's look at this. And again, my disclaimer is this is not my suggestion for an experiment. So, if an entire class went out drinking the night before a test in their 7 a.m. class, we could survey them to see how many drinks they had and then see what grade they made the next day, right? Could that affect you? Especially if you had a few drinks, or it depends also on what the hell you're drinking, correct? Okay. Both of these pictures, what would you say the trend is? Do you see a trend? It's especially evident here, but it's also here.
Looks like the more grades you have, the more likely your grade is going to be lower.
Exactly. Which one of these has a stronger relationship? What's your gut tell you? Yeah, this guy. It's got a stronger relationship, right? Do you guys see that? Because it's more lockstep. If the relationship is stronger, as one variable changes, the other one should change lockstep with that. That would mean a strong relationship. This one, are there some outliers in this one? Like, here's the general trend. Do you guys kind of roughly agree with me? Everybody cool with the fact they just drew a line to represent the trend? Isn't that line like a two-dimensional average? Would anybody agree with me? And you're all like, whatever keeps this moving, man. All right. That is a two-dimensional average. It kind of like averages out where all the points seem to be. This one, another kind of measure of strength is which one has points that get further away from that. And wouldn't that be kind of related to a two-dimensional standard deviation? Which is cool because that formula I showed you had elements of standard deviations in it. Okay. Who's this person?
You either have a lot of beer.
What'd you say?
An outlier.
Oh, outlier. I'm sorry. I thought you said they got lit. This person drank a lot, but they still managed to make a high grade. Now, we don't know the scale, right? So that's a good section 1 problem. There's no scale. But whatever the scale is, they did relatively good. They did the 4th highest grade. But they also drank, they were tied for the most drinks, it looks like. Yes? So that's just a person that could hold their beer. That could maybe they don't get a hangover, right? Lucky.
Just studied really hard.
Plus they just knew their shit, right? Well, who's this person then? Man.
Can't hold his beer and he can't study.
Well, you didn't drink them.
Did not drink a lot. But,
Doesn't know he's in either.
yeah. So no matter how much this guy drank, unless it's some kind of magic, like, understand statistics potion, he would have been done bad either way. Are you guys kind of with me? So which one of these is more realistic to real life?
The first one?
The first one, yeah. I would expect there to be people, I don't care how much they drink, they're going to do bad or good. But in general, there should be some slight effect. Would you agree with me? In fact, this is even probably too pronounced, to be honest, right? But this is definitely way too pronounced. That would be very strange, right? Okay. Okay. So this one is stronger because the points are closer to the line that averages where they are. Okay. Yes.
Why does the second one look more fixed than the first one does?
Because I made it that way. Yeah. Sorry. Obviously, these are just made up. I didn't actually have
I
my.
know they're made up. It just kind of seems like in an example like this, it seems more fixed. It'd be more or less kind of making the point like you're making versus the second one. The first one actually looks more realistic.
Yeah, exactly. I love it. So, and that was part of my point, is in real life, we're going to expect there to be variability. Now, in real life, if I track the height of a baby from when they're born to when they're 3 years old, wouldn't you expect that to be sort of, it wouldn't be a straight line, but it would certainly be pretty much the same kind of shape. Some babies, of course, you know, I don't know if anybody has a baby. You have these these diagrams that sort of look like this, and you have a line down the middle. So this is the average height, for example, and then this is like one standard deviation away, one standard deviation away. Okay. So I don't know if you've ever seen that kind of picture, but okay.
The nutrition chart for height.
Yeah, height and weight. Yeah, so one of my friends, they named their kid Max, and then he was like 98th percentile in both height and weight. It's like, you named that person well. Max, and now he's like 6'8" or something crazy. Anyway. So, would you say that this trend is negative or positive? Negative. In fact, as the beers increase, it seems as if the grades decrease. Okay, lovely. Okay. So what we're going to want to do, well, let me do this next example real quick. Same questions. Which one of these is stronger relationship? This one. This one's stronger because, again, it's tighter to the line. And again, I have outliers. This person barely studied, but, you know, they made a good grade. Maybe they already took the class. It's the first test. It's the stuff they were okay with. Or it's just somebody who just knows the shit, right? And then you got this poor person or these poor people. Okay. Now, is this a positive or negative relationship? Positive, of course. It's going up. It's sort of related to slope, right? What we're going to want is we're going to want a number that represents how strong the relationship is. And we're going to want a formula for the line. And the funny thing is, this line, this is not something I made up. This is called the line of best fit. Line of best fit. Sounds like the ring of invisibility. Right? It's the line of best fit. I don't know. Today I'm all about Lord of the Rings. Blah, 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 blah. It would be great if there was some way to find a number. We call these relationships correlations. So I don't know if anybody has ever heard of a correlation. Two things are correlated when one changes and the other one seems to change. Or at least, let me say it a better way. When we notice an element that has one set of data point and the other data point kind of follows a general trend. That's a horrible way to say it. So let me say this. Let me say something really silly. If I went out and watched a bunch of people playing basketball, and then I saw the people that don't play basketball, one thing I could write down is, it seems that playing basketball makes you taller. Is that true? No. But if it was an alien and they just saw people, they play this thing with a hoop and a ball and it seems to make them taller, that would be, on a very surface level, it would make sense. Now, obviously, we know better. It's the other way around, correct? If you're taller, you have a better chance to play basketball. I know there's Muggsy Bogues and Spud Webb and all these people. Okay. So the problem with correlation is it doesn't tell me if one thing actually causes the other thing to change. So for example, what I'm about to say is a true statement. When teachers' pay increases, liquor sales go up. Does that mean that teachers are all drunks?
No.
What does that mean?
Could mean that the economic state of wherever they are is doing better. and people
So
are there.
everybody, or a lot of people's, or maybe everybody works for the government, or everybody's pay goes up. Then people are going to be able to afford luxuries, right? And well, for some people, liquor. Well, anyway, more people can afford it then, and they're going to buy it more. But so this is why. One thing I want you to come out of this classroom with is, if somebody presents you with a statistical analysis, you now should know what to look for. Okay, how did you pick your sample? How big was your sample? How certain are you about what you see? Right? These kind of things. And I can say that. I can say, oh, we see that when teachers' pay goes up, liquor sales go up. Therefore, all these teachers are in these classrooms, they're all drunk, and oh my God. That's a stupid example of exactly what's happening in a lot of freaking media nowadays. A lot of news stations. They'll say something that is effectively true, but it conveys a false image. That is a true statement that I made, but it conveys a false idea. Okay. Blah, 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 blah. Here's the idea. this number that represents the strength, it can be from -1 to 1. -1 would mean it's a perfect, so this would be a -1 correlation. Would be they all perfectly line up on a negative slope. That would be R equal to -1. So R is the variable we use to represent the strength of the correlation. So if it was perfectly lined up in a negative fashion, R would be -1. So not surprisingly, what makes R equal to 1? Positive, and they're all lined up perfectly. The minute I pull a data point away from the line a bit, R starts going towards 0. What do you think R equals 0 would mean?
No correlation.
No linear correlation. Yeah, so that would be something like there's just no apparent trend line I could see, right? Okay, maybe. Yes?
So is R like an average of every point's distance to the line?
R is another name for the line of best fit is the least squares line. It's the line that minimizes the squared distance from the line to every data point. R is kind of a measurement of that distance in a sense, yes.
So if you had two, like let's say you have like a perfect correlation, like R equals 1, right? Could you have 2 points that are equidistant from the line exist? And because the each distance would be...
The minute I have points that are not on the line, R is less than 1.
So it would be like, oh, the distance of this one to the right cancels out the distance.
No, yeah, it doesn't cancel out.
Okay.
It's sort of like, it's exactly, okay, the data 5, 5, 5. If I have a data set 5, 5, 5, can you tell me what the standard deviation is?
No.
Yes, you can. If the data is 5, 5, 5.
0.
What's the standard deviation? 0. Mean is 5. How far do the data points get away from that? 0. Everybody with me? If I make this 5, 4, and this 5, 6, 4, 5, 6, standard deviation is not 0 anymore, correct?
Okay.
So if I have one on one side, one on the other side, that's sort of like the numerical equivalent of your visual.
Yeah.
Okay.
You know the equidistant is...
R is a measure of how tight the points get to the line.
Okay.
Okay. So let's see. Yeah, let me do this. Let's do this. So look on the other side real quick. I copied this from the calculator guide that's up on Canvas that you could print out if you wanted to. But I just copied it. The work we're going to do is we're going to put like list 1, list 2. We're going to put one set of data in list 1, one set of data in list 2. So we'll do that, and then the calculator will be able to calculate for us the line of best fit equation, and it will be able to calculate for us the R value. It'll be on us to interpret what we see, but I'm going to let the calculator do the bulk of the calculation for us, finally, for once. Okay. I think we're going to do that tomorrow. I think that's plenty. I think we'll have a nice early day, as I promised. Everybody got a practice test, right? So I'll have the answer key for that tomorrow. I have the quizzes graded tomorrow. Yeah. Thank you for putting up with me. I seem to be extra goofy today. Oh, yeah.
I'm just curious about like the calculation on the quiz. Do you mind if I just put it in and see if I messed it up? Like, am I allowed to do that?
Oh, thank you. Is this you? Yeah. Thank you. You too. Let me see. What are we looking at, Sean?
Okay, it's it's at the very bottom. It's the last one. There we go. Yeah. So Z P hat Q hat
Wait, what does it say?
0.188 my Q hat.
1. 879. Oh, so you just made it 188.
It's A121 for that one.
Yeah. Oh, no, I know. But I was
Oh,
just saying
yeah.
1879. Okay.
Yeah. Oh, I probably should.
And then you didn't square .03. That's what happened.
I didn't square it. Oh,
Yeah, okay.
damn.
There you
That's
go.
what I did. Okay.
Not a huge problem. So you only lose like 28 points. No.
I was so sure I did that right because you were talking about. I was like, I know I.
It's so easy to forget those squares, man. Yeah.
So for the p-value, is the only like point of the p-value to compare it to alpha to see if it's below alpha?